All right, this is Module 4, Lesson 5. We're going to talk about percent increase and percent decrease. So let's look at this opening exercise. Cassandra likes jewelry. She has 5 rings in her jewelry box. So let's sketch the 5 rings. Good thing I'm a math teacher. All right, so let's draw a double number line diagram relating the number of rings as a percent of the whole set. Now, last year you learned how to draw double number lines. It's exactly what it sounds like. It's 2 number lines. Okay, we're going to make this our 0. We're going to label the top as the percent. And we're going to label the bottom as number of rings. Now, your whole always represents 100% of the collection. So at 100%, there are 5 rings. So we want to know how many or what percent is each one of these rings. Nope. 1, 2, 3, 4, 5. All right, well, if we split 100 into 5 sections, we know that each ring would be worth 20% of the collection. So here's our double number line that represents this ring collection. So what percentage is represented by the whole collection of rings? So the whole always represents 100% of the collection. What percentage does each ring cost? So each ring would be only 20% of the collection. We divide 100 by 5 to get each ring to be 20%. So let's look at example 1. It says Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will the percent increase be? So we want to know how much will her ring collection increase by? What percentage? So we're going to start off with our little cheat sheet. Part equals, percent equals, and whole equals. Now, the whole is the total number of rings. Originally, you always do the whole as the original amount. So in this case, it would be 5. Okay, if you want to make a little note to yourself over on the side, the whole is always the original amount. Now, the part is the new amount. In this case, there are 6 rings total now because we are buying 1 more. And we want to know what percentage of increase that is. So let's do part equals percent times whole. My part is 6. My percent is X. My whole is 5. All right, let's solve for X. So we're going to divide both sides by 5. So take your calculator and do 6 divided by 5, which is 1.2. Now, that's not 1.2%. Remember, you have to move it over twice. So this is talking about 120%. Now, that's not our answer. Now, remember when I said that the whole amount is 100% of the collection? So we always start with 100%. If we started with 100% and now we have 120%, then our increase, we're going to subtract it from 100, is a 20%, and we're going to label that as an increase because it went up. So this right here is our answer. And a lot of people forget to do that last step when they're doing percent increase and decrease. Now, it doesn't make sense that it went up by 20% when she added 1 ring. Well, look at each ring is 20%. So if you add 1, it's going to go up 20%. So that does make sense. All right. I'm going to try this with you again. So look at the next page. Okay. Exercise 1 says, John increased his trading card collection by 5 cards, and he originally had 15 cards. So what is the percent increase? So I'm going to do my cheat sheet here. Part equals, percent equals, and whole equals. I'm going to remind you that whole is the original amount, so that would be 15. The part is your new amount, which would be 20 because he added 5 cards, and we're trying to find the percent. So part equals percent times whole. So the part is 20. The percent is X. The whole is 15. Let's solve by dividing both sides by 15. So I'm going to bring my calculator into this. 20 divided by 15 is 1.3 repeating percent. I'm sorry, that is not the percent. That is 1.3 repeating just for X. We have to move it over twice, which would give us 133.3 repeating percent. Now, that's not our answer. Remember, we started with 100%. So now when I increase it to 133.3 repeating, we're going to subtract it. Now, actually, I did that backwards. I should have my bigger number first. 133.3 repeating minus 100 would be 33.3 repeating percent. And we are going up. So we're going to say that this is an increase. So we're not increasing by 133% because that would mean we're more than doubling our collection. We're only going up by a 33.3 repeating percent increase. Suppose instead of increasing the collection by 5 cards, he increased his 15-card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1? Remember, when hers increased by 1, it was a 20% increase. Would this be a 20% increase? Well, let's find out. So percent, let's do our cheat sheet. Our original amount is 15. We now have 16. So let's do part equals percent times whole. So our part is 16. We don't know our percent. Our whole is 15. If I were to solve, I'd do 16 divided by 15, which is 106.6 repeating. I'm sorry, it's 1.06 repeating. Then I move it over twice to give me 106.6 repeating. Now, that's not my answer. Remember, we have to subtract 100% to find out how much it's going up. So this time it is increasing by only 6%, not 20%. Now, why is that different? They're both 1 card or 1 ring. Why is that different? Because the whole is different. So now it's out of 15 rather than 5. All right, so let's do some more practice. Example 2. I'm not sure who this is, but he earned 8 badges in Scouts as a Scoutmaster's last report. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before the Scoutmaster's next report. If Justin completes the additional 2 badges, what will the percent increase in badges be? So let's set up our cheat sheet. So now our whole is our original amount, which would be 8. Our percentage is what we're trying to find. And if he completes 2 additional, that would leave now 10 badges. So part equals percent times whole. So 10 is equal to X times 8. We're going to divide both sides by 8. So X is equal to, let's do 10 divided by 8, which is 1.25 or 125%. Now we have to subtract 100, the original amount, which would leave me with a 25% increase in badges. Now it says express the 10 badges as a percent of the 8 badges. Remember, of is the whole. 10 badges would be the part. So part equals 10, percent equals X, whole would equal 8. This is what we just did. So that means that part is percent times whole. So our part is 10. Our percent is X. Whole is 8. divide both sides by 8. So we get 1.25, which is 125%. Now we're not subtracting there because that's what the percentage is. Now, does it make sense that if you do 100% plus the 25%, you get 125%? And the answer is yes, because 10 is more than the original amount, which means that it's going to be more than 100%. That's where that 125% comes from. All right, we're actually going to stop there. We'll continue this lesson tomorrow. You're going to complete the problem set. Make sure you look at the backboard because you are not going to be doing the whole problem set tonight. All right, good luck.